Good. So this one has to be 51 degrees. This one has to be 39 degrees if you use the fact that triangles have 180 degrees to deal with. And since all of the angles are congruent, all angles congruent, then triangles are similar. Now, there was an extra part of this question that said, write a similarity statement. Guys, if we are not being detailed in our answers, okay, you're going to lose points because there was a question similar to this on our quiz. So, what would be an example of a similarity statement? Emma, go for it.
Triangle ABC is similar, a little squiggly thing, to triangle MLN.
MLN. Yep. Okay. Now, guys, what is the difference between this symbol and this symbol? Christina? Good. This one means that it's congruent. If you put the congruence symbol on your quiz, you lost points, okay? Because nothing other than the angles should be congruent, right? So when you're listing the angles, those should be congruent. Are the sides of these two triangles going to be congruent? No. They're going to be similar, okay? The proportions of the sides, so AB over LM is going to be equal to, okay? But when you're talking about sides, okay, specific sides, you cannot say that AB is equal or congruent to LM. Are we cool on that stuff? We need to be very specific about our notation. All right, number 2. Are these two triangles congruent? I'm sorry, similar. No. Why?
Because when you add 41 plus 93 and subtract that by 180, you get 66, not 64.
Good. This is 66 degrees. And then this means that we only have one set of congruent angles. Okay? Not similar because not all angles are congruent. What was that, Talia?
Did you have to add 93 and 21 and subtract that by 180?
Yes. So technically to find this 66, we just did 180 minus 21. And that should have given us 159. And then you subtract 93 as well, which should have given us 6 and 6. You could have done the same thing with the other triangle, and you would have gotten like 95 degrees. Did anyone do it that way? No? Well, if you do it that way, it would have been 95 degrees. Okay? Questions on the warm-up? (8.3), okay? So we are proving triangles are similar by 2 different methods. The one that we learned so far is the AA theorem. Do you guys remember that? If you can prove that 2 triangles have 2 angles that are congruent, then they're similar. The next theorem that we're going to learn is side, 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 and side angle, side. Now, remember, these are different than the side, 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 side angle, side that we learned for congruence. Do you guys remember those theorems?
Yeah.
Now, when we say that sides, right, in a similarity theorem, they're not going to be congruent. What are they going to be? Proportional. Yeah, similar or proportional. So when we're talking about these, I want you to write down that anything with a side is going to be proportional, not congruent. Okay? Proportional, not congruent. Side similarity theorem. If corresponding side lengths of 2 triangles are proportional, guys, we are going to stress this so much, okay? They are not congruent, they're proportional. Then the 2 triangles are similar, okay? That means we can take any 2 sides that match up. We know that ABC is going to be similar to DEF, okay? So all we have to do is prove that each of the sides has a proportional corresponding side, okay? So let's take AC, for example. AC, we're going to match up with FD. or DF, right? So this is going to be AC over FD should be equal to, let's pick two other sides. AB, what's AB going to match up with? DE. So this should be AB, oopsie daisies, let's write with a pen, AB over DE, which should also be equal to, our last one we'll do CB over FE. All right, AC is what? It's 10, right? What's FD? 10 over 5 should equal AB, which is 8 over 4, which should be equal to 6 over 3. All of these fractions simplify to what? 2, 2, and 2, right? So if we can prove that all the sides are proportional, then we know that the two triangles are similar.
So this is kind of like what we did on that one question during the mock quiz.
Mm-hmm.
We had to figure out if they were similar.
Mm-hmm.
Okay.
So now before, right, the only similarity theorems that we knew was we knew that there was one for triangles, right? If two angles are congruent, then that third angle must also be congruent. And the other way we knew it is if all of the angles in any figure are the same measure as all the angles in the other figure, then they have to be similar, right? So now we're saying, all right, there's a similarity theorem for triangles that says if all of the sides are proportional, then the two triangles must be similar. So a side angle side similarity theorem, okay? And it says if an angle in one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So in other words, all you need are two sides that are proportional and an angle in between them that's congruent, okay? So for this one, you would need to write AC over what side in the smaller triangle?
DE. Wait, no.
DF is equal to AB over DE. Do you see how this is different? It's only two sets of sides because we also know that angle A is congruent to what? Angle A is congruent to angle D. Okay? So if you can prove that the angle between the two sets of proportional sides is congruent, then you just need two sides. Do you guys see how that's different? We don't need to include CB and FE. Okay? Now, AC was 10, right? DF was 5. AB was 8. And DE was 4. So we're going to get 2 equals 2 again. So we can apply the side angle side similarity theorem. For now, we know 3, okay? We know angle, angle, similarity postulate. We know side, side, side similarity theorem. And side, angle, side similarity theorem, okay? Now, we've been using theorem here, so you can cross out this postulate and just put theorem, okay? Are there any questions in regards to these 3? So if we're like working at Home Depot, right? And we've got an apron, we've got 3 tools right now. We've got AA similarity theorem, SSS similarity theorem, and SAS similarity theorem, okay? And let's do some examples. Theorem do you think I'm going to use?
SSS.
Side, 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 okay? Because we don't know any. Here we go. Example 1. The measures of the sides of ABC are 4, 5, and 7. And the measures of the sides of X, Y, and Z are 16, 20, and 28. Are the triangles similar? Okay? So, down below I want you to write letter A. Are we given any knowledge about any of the angles? No. So go back. Think about the angles, okay? Now, when we're matching up sides, the smallest side of this triangle should match up with the smallest side of the other triangle. Do you guys see that? So the 4 in ABC should go over what? The 16. And then same thing. The second smallest side of ABC, which is the 5, should match up with the 20. Do you guys see that? So this 4 over 16 needs to equal 5 over 20. And then last but not least, the 7 needs to go over 28. Let's see if this holds. What is 4 over 16 simplified to? Giselle?
4 over 16 is, I thought it was a 2 over 4.
Close. Xavier? 1 over 4. Because, right, the 4 is divisible by 4. It cancels out, gives us 1, right? And the 16 is divisible by 4, cancels out, gives us 4. What about 5 over 20? 1 over 4, right? We divide both the top and the bottom by 5, right? So this would be 1, and this would be 4. What about 7 over 28? 1 over 4. Okay, this becomes a 1, this becomes a 4. So if we can show that all of the proportions are equal, what theorem are we applying? Side, 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 similarity theorem. Yes. Because side, side, side theorem is different. Okay, that's the congruence theorem. Okay, so side, side, side similarity theorem shows that triangle ABC is similar to triangle XYZ. Do you guys see how I'm very specific with my notation? I'm putting a similar symbol, not a congruent symbol.
Yeah.
Okay. Squiggly means similar. Yep. Any questions on A? What do you mean? Yes. So we had to set up the proportion for all of them. Like you couldn't just put 4 over 16 equals 5 over 20 because we don't know any of the angles. Okay? All right, and B. Now B, it's giving us actual sides. So B, it might be helpful to actually draw both triangles. So let's go ahead and draw them. Let's call this example B over here, and let's draw ABC. And let's draw a little bit larger XYZ. All right. We know that the length of AB is what? 2, right? AC is 5. And BC is 6. So we have 2, 5, and 6. And then in the other triangle, XYZ, XY is 2.5. We know that YZ is 2. And we know that XZ is 3. Is ABC similar to XYZ? Now, since they write it like this, right? We have to use this similarity statement when we're setting up our proportion, okay? So, the side AB, right, is our first 2 letters. What side in the other triangle should that be proportional to? Zoe? XY, okay? So that's where we're going to start. We're going to say, all right, we need to put AB over XY. That should be equal to, let's go to BC next. BC over YZ. And the last one is going to be AC over what's the last side, guys? XZ. Are you guys with me? Mm-hmm. All right. What's the length of AB? 2. What's the length of XY? 2.5. What's the length of BC? I have 6 here.
Oh,
Yeah, it's 6. And what's the length of YZ?
2.
2. What's the length of AC?
5.
And what's the length of XZ?
3.
3. Are these going to be the same ratio?
No.
No, certainly not, okay? None of these will be equivalent to each other, okay? So we say that the triangles are not similar.
What about, like, for a not similar sign, do you do a squiggly and then a line through it?
Ah, you could do that, yeah. So if you wanted to put a squiggly and not, like, not similar, I don't know if that will actually work.
Because that looks like an X.
Yeah, I wouldn't put that. I don't think that's actually a reasonable geometry symbol. I would just put not similar, spell it out. Okay. Now, guys, let's imagine that it asked us, it just said, will triangle ABC be similar to XYZ? And it didn't have this similarity statement, okay? We would need to match up the sides based on their length, okay? So, what is the smallest side in ABC? It's 2, right? You would put that proportional to the smallest side in XYZ, which is
2.
2. So you'd put 2 over 2. And then you would set that equal to, what's the second one in ABC?
5.
5. What's the second one in XYZ?
2.5.
2.5, okay? You would set up that proportion. It's also not similar if you do that, okay? But I want you guys to be able to match up smallest sides with each other, medium sides, and then biggest sides. Cool beans? All right, let's do another one. Ever not given this similarity statement, say this was not given to us over here. You would have to match up smallest with smallest, medium with medium, and biggest with biggest.
So wouldn't the smallest with smallest be 2, 2 instead of 2 and 2.5?
Yeah, that's what I'm saying. Should be 2 over 2.
But then the equation's different.
Yes, it would be different.
Oh, okay.
So I'm saying in a hypothetical situation, this problem would change. B would change. Okay. We're skipping this one. Put skip.
Wait, what?
Can we just
I'm
delete the
confused about
slide?
that last part.
Okay, so if you're, all right, so skip example 2, example 3. What?
We just delete.
You can delete the slide, yeah. All right, name the similar triangles and give the postulate or theorem that justifies your answer. Are these two triangles similar, and how do you know? Christina.
I think because they share angle A.
They share angle A. There we go. So angle A is congruent to itself, and this one's congruent to this one. So what theorem are we applying here? Xavier? Angle, angle, similarity theorem. Now, before we can apply it, we have to write the two angles that are congruent. So we said angle A is congruent to what? Angle A. Notice the difference in marks. You see I'm using the angle is congruent to an angle. And we also know what other two angles. And if you say angle D, I'm going to lose it. Giselle?
Angle B and angle.
Angle B is congruent to?
Angle B.
No.
Oh. No, it.
Gabby? What? Angle D is not an angle, guys. Kaylin? ADE. Thank you. Guys, if you put angle D on your quiz, you lost so many points. Okay? I've gone over this since day one. Angle D is not an angle. What other angle should we never list? Angle E. Because there's two angles there. We need to be very, very specific about which angle we're talking about. Are we Gucci at this point? So we proved two angles are congruent, therefore we can apply the angle-angle similarity theorem. Cool beans? Zoe, what's up?
Is there a name for angle A like that?
Say that one more time.
Is there like a name for it instead of just calling it angle A? Is it congruent to angle A?
You could say that it's the reflexive property, but you don't need to put that for me. Okay? Yes, Gabby. BAC and DAE. You could if you want to, okay? But you can label it as angle A because do you see how there's only one angle at angle A? There's only one possibility for angle A. If you wanted to label it with the 3 letters, that's totally cool. All right. B. Well, let's first think, what theorem could we use here? Savannah?
SAS similarity.
What's that?
SAS similarity.
Very good. Why?
Because C is congruent to itself and the sides are proportional.
I love it. It's side angle side similarity theorem. Because we know that C is congruent to itself and C is included in both triangles, okay? So we're going to say angle C is congruent to angle C. That's the angle portion. Now we just need to prove that 2 sides are similar, okay? All right, let's try to set it up. Giselle?
So wait, you would do CD and CA?
Good. CD over CA needs to be proportional to what?
To,
Go ahead, yeah.
CE and CB?
Good. CE over CB. Do you guys see how we're taking the smaller side of the top triangle over the bigger side of the whole thing?
Yeah.
So it's CD over CA, and then this is CE over CB, okay? So my numerator is the smaller one, my denominator is the bigger one. All right, what's the length of CD?
6.
And CA?
9.
9. Because you have to add the 6 and the 3. Do you guys see that? Okay, what about CE? 10 and EB? 15. Okay, let's simplify these 2 fractions. What can 6 over 9 simplify to? 2 over 3. We divide both the top and the bottom by 3, right? What about 10 over 15? 2 over 3. Okay, you can divide both the top and the bottom by 5. Are these the same?
Yeah.
So we can apply side angle side similarity theorem. Do you guys see the difference? Do you see how that C angle being congruent to itself only made us prove that 2 sides were proportional? Okay? We didn't have to prove that 3 sides were proportional. Okay? All right. In example C, what do you think we're going to use here? Xavier? Why? Because what?
We're only given sides.
Very good. We're only given sides. We're not given any of the angles. So we know we need to use side, side, side similarity theorem. All right. Now, we need to match up smallest with smallest, medium with medium, and biggest with biggest. Okay? So what's the smallest? Let's take a look at this triangle right here in the top, the smaller one. What's the smallest side of that one? It's LK, right?
Yeah.
So we're going to put LK over, what's the smallest side? Be careful here, of KMO. KNO, excuse me. It's KO, right? Which is 6, right? All right, now let's go to the next one. So the medium side. What's the medium side for LMK? LM over. MN is not a side of that triangle. It's NO, okay? Because what's the length of KN, guys? It's going to be 12. Because this section is 6 and this section is 6. Do you guys see that? Yeah. KM is 6 and MN is 6. So this whole thing is 12. 6 plus 6, okay? All right, so now the last side is going to be KM, right? Over KN, yes. All right, let's see if it works. LK was 3. What was KO? 6. So 3 over 6 should be equal to LM, which is 5, over what's NO? 10, which should be equal to KM, which is 6, over KN, which is 12. These are all going to simplify to 1/2. 1/2 equals 1/2 equals 1/2. So this is side, side, side similarity theorem. Yeah, Christina? I lost you on this one?
Well, you're trying to find the sides, I would
Okay, so remember, there's no statement for us to use, right? Because normally if there was a statement, right, we would just match up like the first and the second letter with the first and the second letter over here. Do you agree with that? So now, this is when I said you have to go from smallest to largest. So the smallest side of the smaller triangle was LK. Do you agree with that? So we put the LK over. That has to be proportional to the smallest side of this triangle. And the sides over here are 6, 12, and 10. So it has to be LK over KO.
Oh, is it because you have K and then is in the side, right?
And then is not a side. It's only
That's why
half
you
the
combined
side.
it. So is that what it is?
So I combined MN with KMs to make the full side of this triangle, okay? So if it helps you, definitely use a highlighter to highlight both of your triangles. And you'll see, do you see how this triangle, it's not just 6 and it's not just this 6, it's both of them combined, so it'd have to be 12. All right? Good questions. Any other questions on this one? All right. You guys, help me.